The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to continue in chapter 11. We're going to look at section 11.5, part 1, and then tomorrow we'll look at part 2. And so yesterday we talked about logarithms, and we talked about log base 10, and that 10 was commonly used. It's called common log, so the notation log base 10 can be written just log. Okay. We also looked at going back and forth between exponential and logarithmic forms. Today we're going to look at a new base. Rather than base 10, we're going to talk about base e. Okay, now e is a number that is approximately 2.7, and we're going to be using it when we're dealing with exponential growth or decay, where it's in a continuous situation. And I want to back up a little bit and say that pi is an irrational number that is approximately 3.14. Pi is used whenever we're dealing with things like circles or spheres, circumference, the area of a circle, the volume of a sphere. Pi is involved in that. E is involved when we're using continuous exponential growth or decay. If a situation like a population is increasing or decreasing, often E will be involved in that situation. Pi is a little more than 3, E is a little bit less than 3. Now, let's talk about population. Let's say Yakima County. Now, in Yakima County, over the course of a year, is this the situation where no one is born and no one dies until December 31st, and all of a sudden a bunch of people are born and a bunch of people die and the population changes? No, it's a continuous thing. So anytime you've got a population that's increasing over time or decreasing over time, it tends to be a continuous process. When we're dealing with that continuous process, that's where E is often involved in the formulas. Now, because log base 10 is used quite frequently, mathematicians called it common log, and again had the following shortcut notation. Well, log base E is also used quite frequently, so the notation they use for that is ln, or natural log. Now, why isn't it NL? I don't know, but anyway, so not only is log written like that, log base 10, but ln means log base E. If you look on your calculator, on the far left column, typically either above or below the button that says log, which is log base 10, you see the button ln. And notice that the second function key is e to the x, just like the second function key of log is 10 to the x. This will help remind you that ln is log base e. All right, now let's take a look at some problems involving base e. And let's start out with this. Okay, this says find A using the formula A equals PE to the RT power, given the following values of P, R, and T, and it says round to the nearest hundredth. Okay, this one says P is 5,000, R is 8%, and T is 20 years. 8% is going to be written as a regular decimal number, not as a percent. So plugging the numbers in, we get the following. A equals 5,000 times E raised to the 0.08 times 20 power. Now, on your calculator, recall that there is the button that says e to the x, which is the second function of ln. So what I can do is I'm going to type in 5,000, okay? Then I'm going to type in the second function key and then push the ln button. And by doing that, I will get e to the x, okay? And what it's going to show up is this. So it's got that little caret and then parentheses. And inside of there, 0.08 times 20, and then close that up, push equals, and I get 24765.16212. And the directions said round to the nearest hundredth. So that would be this place. The 2 would round down. So we're going to get 24765.16 to the nearest hundredth. All right. Let's take a look at another example. Here we have, let's see. Again, we're going to use A equals P e to the RT. And in this case, P is 15,895. R is negative 2%, and T is 16 years. Now, notice that the rate is negative. So this situation is not going to be growing, it's going to be decaying. So A is 15,895 times e to the negative 0.02. Recall that this is going to be that times 16. Okay, so 15,895 second ln. So I've got this. Okay, then I'm going to put in negative, not the minus sign, but the negative 0.02 times 16, close it up, equals, and I get 11542.13894. Rounding to the 100th place, the 8 would round up in the 1,000th place, so we get 11,542.14. All right. Now we're going to evaluate some expressions without using a calculator. Let's see how that works out. Okay. We have the natural log of e to the 5th power. All right. We don't know off the top of our heads yet what that's equal to, so we'll say that it equals to some unknown quantity that we'll call box. Now, ln means log base e, but I have the natural log of e to the 5th power. All right, so this becomes that, but that e to the 5th power is still there, and this equals box. Taking this logarithmic equation and putting it in exponential form, we get e to the box equals e to the 5th power. Therefore, the box is 5. So the natural log of e to the 5th power is 5. Okay, let's take a look at another example. The natural log of e to the 4th. Well, that's equal to some unknown quantity box. ln, natural log, is log base e. So we have log base e of e to the 4th power equals box. Changing it to an exponential equation, e to the box equals e to the 4th, so the box equals 4. Natural log of e to the 4th is 4. Are you seeing a pattern there? What do you think the natural log of e squared would be? You're right, it's 2, if that's what you were guessing. How about this one? The natural log of 1 over e cubed. Well, that's equal to some unknown. Natural log is log base e of 1 over e cubed, so that equals box. E to the box equals 1 over e cubed, but isn't 1 over e cubed e to the -3 power? Now we're used to taking something like that and writing it with a positive exponent. But in this case, we want to write it so that we've got e to the box equals e to some power. So the box is -3. So the natural log of 1 over e cubed equals the natural log of e to the -3 equals -3. Okay. How about this one? The natural log of the 4th root of e cubed. Well, that's equal to some unknown quantity. Again, natural log is the same as log base e. So we've got e to the box equals the 4th root of e cubed, but isn't that e to the 3/4 power, changing this radical into exponential form? So the box is 3/4. All right, now we're going to use our calculators to come up with some values. And it says, use a calculator to evaluate each expression. If possible, express all answers to 4 decimal places. The natural log of 0.675. Okay, now we're going to push the button that says ln, not the second function key. We don't want e to the x. We just want the natural log or ln button. And when I push it, I get that. So then I'm going to put in 0.675. 0.675, close it up with parentheses, push equals -0.393042588. However, it said round to 4 decimal places, so that would be right there. The 4 would round down, so we're going to get -0.3930 as our final answer. And let's take another one, the natural log of 2.7. So on our calculator, natural log 2.7, close it up, equals 0.993251773, rounding to 4 places. The 5 is going to round up. So we're going to get 0.9933. Okay. Now it says solve each equation. Express all answers to 4 decimal places. We have the natural log of x equals 1.4023. Now, keep in mind, again, that ln, natural log, means log base e. So we've got log base e of x equals 1.4023. We can take this logarithmic equation and rewrite it as an exponential equation, e to the 1.4023 equals x. We can plug that into our calculator. So now we're going to use the second function key. So the second function key and then ln, which is going to get us e to the, and then we'll put in 1.4023, close it up, push equals 4.0645376661, and it said 4 decimal places again. So right there, the 3 rounds down, so we get 4.0645. There we go. Okay, and let's see. Let's do another one of those. The natural log of x equals -0.28. So this is log base e of x equals -0.28. So e to the -0.28 equals x. And on our calculator, second ln, which gives us e to the, and then we put in negative 0.28, close it up, push equals 0.755783, etc. Rounding here, the 8 rounds up, 7558. Okay, what I want to do now is I'm going to go back and do a graph. And so I'm going to pause the recording. All right, we'll start the recording back up and we'll look at a graphing screen. And what I want to look at is f of x equals e to the x power. All right, now keep in mind, e is slightly less than 3. It's approximately 2.7. So let's make a table and let's see what that graph would look like. X and y, we're going to use -3 all the way to +3. All right, now f of -3 equals e to the -3 power. And on the calculator, e to the -3 power, I'm getting 0.049787. I'm going to round these off because I'm not going to be graphing it super accurately. In fact, let me move this out of the way here. So I'm going to call that 0. Well, maybe I'm going to call it that. Hang on. I'm going to call that 0.05, rounding to the 100th place. And I may not do that consistently in this. I just want to get some rough information. Okay, x is -2, f to the -2 power, excuse me, f of -2 equals e to the -2 power. Okay, which is 0.135, I'll call that 0.14. F of -1, e to the -1. And let's see here, e to the -1 power. That's approximately 0.367, so we'll call that 0.37. F of 0 equals e to the 0 power, which is 1. F of 1 equals e to the 1, which is just e, or 2.72, rounding off. Let's see. F of 2 is e squared, and e squared is 7.389. So we'll call that 7.4. And I know I'm not rounding consistently here. I'm just trying to get a rough idea. F of 3, e cubed. 20.085, so we'll just call that 20. Okay, again, I wasn't consistent in my rounding, but you'll get an idea of the graph. So let's see, when x is -3, y is 0.05. That's going to be darn close to the x-axis. At -2 we go to 0.14, which is roughly a 1/7, so we'll go up a little bit. And then at -1 we're about a 1/3, and then we're at 1. When x is 1, y is 2.72. When x is 2, y is 7.4. When x is 3, y is 20, which is off the graph. Okay. So it looks very much like 2 to the x, 3 to the x, etc. Okay. But you need to come up with the values using your calculator and that e to the x button, which again is the second function key of natural log, or LN. All right, give me just a second here. I think that pretty much does it for what we're going to look at today. So just some reminders that Thursday, there will be no office hour. I'll be in a meeting. And this weekend, Saturday and Sunday, I won't be available. I'll be up in the woods. So anyway, I'll be back this afternoon at 1:15 if you have any questions. Otherwise, that's it for today. So have a good day. Bye now.